All right, ladies and gentlemen, what we are going to talk about today is uniform circular motion.
I'm ready.
What are you doing?
Uniform circular motion.
No, not that uniform.
Oh.
Like constant speed uniform.
Oh.
All right, so what we're going to talk about today is actually uniform circular motion. So what is uniform about the motion is this mouse is an example of uniform circular motion. It's traveling at a constant speed. Now, remember, speed and velocity are related, but they're two different things. Even though the speed is constant as it's going around in a circle, the velocity is not constant because velocity, being a vector, has both magnitude and direction. Because it's constantly changing direction as it goes around in a circle, that means we're constantly changing velocity. And because we're constantly changing velocity, any change in velocity that occurs requires an acceleration. So let's kind of talk about the anatomy of uniform circular motion, and not that anatomy stuff that bones and all that. We're just talking a little diagram here. So here's my nice diagram of a circle, not bad by me. Let's say we're going to look at that mouse as though it's at the very top, and I'm spinning that clockwise right here, so around like so. So we have the term tangential velocity, and in math, tangent means it touches a curve at one point, and that's exactly what we have right here. If my mouse is at the top, that means its velocity is going at a line tangent to the circle. So what that really means is if I was spinning it around like so and was to just let go of that mouse or the cord itself, it would go flying off at a line here. Same right here. If it were traveling at this point right here, the tangential velocity would be going down right here. If I were to let go, bam, I'd just spike that right into the ground. So let's look at this top point. Because that velocity is constantly changing, that means that object has to always be accelerating. And by definition, we're talking circular or centripetal motion here. The word centripetal means center seeking. So the acceleration of that mouse is always acting directly towards the center of the circle. So once again, if I was right here, the centripetal acceleration would be going towards the center because it's always being pulled into the center by that tension in the cord. And because I have an acceleration, that means I also have to have a force going to the center. So I would have a centripetal force going towards the center as well. So three new terms there: tangential velocity, centripetal acceleration, meaning acceleration pointing towards the center, and centripetal force, because forces cause acceleration, that'll always go in the same direction as the acceleration itself.
So here's an example of tangential velocity. Man, those Ewoks can fight. Let's look at this for a second. When the Ewok was spinning that sling around and wanted to hit the stormtrooper, right? That stone was spinning in a circular motion. Let's say, stormtrooper over here, stormtrooper.
Naturally.
And let's say that the rock is right here. If the Ewok wants to hit the stormtrooper with that sling, we just learned about tangential velocity, right? So as that rock spins in a circle, the velocity is always tangent to that circle. So when should the Ewok let go of the sling in order to hit the stormtrooper? Well, as soon as you let go of that string, that velocity is going to keep that rock moving in that straight line. So what you want to do as an Ewok, because you may be an Ewok someday battling Endor, you're going to want to let go of that rock as soon as its tangential velocity is in a straight line. Once it's in a straight line, you let go of it, that rock will continue on that path and hopefully wrap around the stormtrooper, bringing him down, saving the rebellion.
All right, so some other examples that we'll see in the future with circular motion or centripetal acceleration are things like cars going around a roundabout, amusement park rides like Ferris wheels or merry-go-rounds, and then also like maybe a record player perhaps. We might even get to do a lab with that. But you're probably thinking, man, I need some math to go with all these concepts and all these new terms. Well, fear not, budding physicist, now is that time. So if you remember way back when, if I was talking average velocity, that is just distance over time. Well, we're going to go back to the first few days of school to define tangential velocity. So we have to say, hey, what distance is that object going around in a circle? Well, guess what? It's traveling the circumference of that circle. So the first part of our tangential velocity formula is actually 2 pi r, the circumference of a circle. Now, the time period, this is another new big term here. The amount of time it takes to go in one full complete revolution, so starts and ends at the same point, would go boom, all the way around to where it started, that is known as the period. So our tangential velocity formula is 2 pi r over t, where t is what we call the period, and the period is the amount of time, or seconds, it takes to complete one cycle. Now, while I'm thinking about it, we are going to need another new term too, that's called frequency. And frequency is the number of cycles per second. So your radio dial, for example, is always measured in megahertz or kilohertz. So the frequency, the units for that are actually hertz, capital H, lowercase z, where the period is measured in seconds itself. So these are the inverse of one another. So we have a few new formulas here: tangential velocity, circumference over the time it takes to make that circumference, 2 pi r over t, and then two other formulas. We want to get centripetal acceleration. This is really common when we talk things like astronauts flying around in circles as they do training to re-enter the Earth's atmosphere. They could pull a lot of g's of acceleration. That is tangential velocity squared divided by the radius, and we all know what the radius is. It'd just be the radius of the circle. And then the last one is centripetal force. Well, guess what? F equals ma, and that's all this is too. We'll commonly write that as m times ac, or sometimes we'll substitute that v squared over r in there, and we'll say fc is equal to mvt squared over r. So those are our new friends: tangential velocity, centripetal acceleration, and also centripetal force. Uniform circular